Hello, welcome to ATI 4205. This lecture will address forecasting. It's a process that drives many logistics decisions. Forecasting the demand will assist in inventory management, supply chain management, location selection, and many other related decisions. Thus, some of the forecasting methods and techniques will be discussed. The forecasting techniques will include qualitative and quantitative approaches and will cover many types such as trends, seasonal, random, and cyclical forecasts. Forecasting is the process of predicting what's going to happen in the future and how would that impact profit, sales, cost, and competition. Predicting demand is an important part of inventory planning and control. Through forecasting, inventory requirements can be identified, such as location, space layout, operations, order picking, and so on. The forecast can be within a short period of time, which is called short range. It can be medium and it can be long range forecast. For the short range, it can be up to 1 year, the medium from 1 to 3, and the long range will be more than 3 years. Medium to long range forecasts deal with more comprehensive issues and support management decisions regarding planning and decisions related to products, facilities, and processes. Short-term forecasting usually employs different methodologies than longer-term forecasting. Short-term forecasts tend to be more accurate than longer-term forecasts. Examples of short-range forecasts will be purchasing, job scheduling, workforce levels, job assignments, production levels. Examples of medium forecasting will be budgeting and sales and production planning. Examples of the long-term or long-range forecasting will be forecasting of a new product, planning, facility location, and research and development. In human resources, forecasting will affect the rate of hiring, training, laying off workers, and many other decisions. While forecasting capacity will prevent shortages in inventory levels, the shortage can result in undependable delivery, loss of customers, loss of market share. The shortage of medical equipment in a hospital can lead to death, especially in the case of pandemic. And in supply chain management, predicting and forecasting supplier behavior in a supply chain can create good supplier relations and price advance. Forecasting follows 7 basic steps. The first step is to determine what are we going to use the forecast for. For example, Disney uses park attendance forecasts to drive decisions about staffing, opening times, ride availability, and food supplies. The second step will be to select the items to be forecasted. For example, to forecast park attendance, we need to count the daily number of people that will be coming to the parks. The third step is to determine the time horizon of the forecast. Would it be short, medium, or long? For example, Disney uses daily forecast for certain operations, weekly forecast for other operations, monthly forecast for different operations, and annual and 5-year forecast maybe for strategies or for other related decisions. The fourth step is to select the forecasting model, which might depend on the collected data or expert judgment or qualitative data. For example, Disney uses the collected statistical data and use statistical forecasts model to forecast the future operations of Disney. The fifth step is to gather the data needed to make the forecast. The sixth step is to use the models to make the forecast. In other words, we need to get the results for the forecasted models. In the last step, the results will be validated to make sure of their accuracy, then implemented through making the proper decision. For example, if we saw that attendance is high, then maybe we need to hire people and assign schedules. Forecasts are rarely perfect because we have outside factors that might affect the prediction or the forecast, and those factors cannot be predicted or maybe even unknown. So they might impact the outcome of that forecast. Most forecasting techniques assume an underlying stability in the system, which is not true, because most of systems again been affected by other factors that might not make the system stable or might affect the stability of the system. Consequently, some firms automate their prediction using computerized forecasting software, then monitor irregularities. Product family and aggregated forecasts are more accurate than individual product forecasts. There are two approaches or methods of forecasting, qualitative and quantitative. The qualitative methods are used when situations is vague and little data exists, such as new product or new technology. It involves intuition and experience. For example, forecasting sales on the internet. It will be very hard, and that's why maybe we can collect surveys, ask people, interviews, and that is considered as qualitative data. The quantitative methods are used when situations are stable and historical data exists, such as using quantitative methods for existing products or current technology. This approach involves mathematical techniques and statistical analysis, including uncertainty and risk, such as forecasting sales of organic or quantum LED TVs. We have the OLEDs or QLEDs now TVs, and we can predict based on information that was collected about other TVs or new product release for TVs. This slide shows some of the methods used in the qualitative approach. More will be explained in the next few slides. The first method is jury of executives or executive opinions, which is the opinions of high-level executives, sometimes strengthened by statistical models. Most likely they learned from past experience. The second one is DELPHI method, which uses a panel of experts and document the most common opinion, taking basically the average of these opinions. The third one is Salesforce composite, and those are estimates from individual salespersons that who are reviewed for particularly then aggregated. The last one is consumer market survey, which collects customer feedback through surveys and questionnaires. The jury of executive opinion involves opinions of small group of high-level executives, sometimes beefed up by statistical models. The group estimates demand by working together. This method combines managerial experience with statistical models. Since you can gather the group of experts in a meeting and in a short time and ask for their feedback, it's relatively quick compared to other methods. The DELPHI method follows an iterative group process that continues until consensus is reached. In the group, we have three types of participants: decision makers, staff, and respondents. The decision makers evaluate response and make decisions, while staff usually administrate surveys, and the responders are the people who can make valuable judgments or respond to the type of decision that they're going to make, and can be forwarded to decision makers to make the proper decision. The third qualitative method is Salesforce composite, where each salesperson projects his or her own sales. The sales will be combined at district and national levels. Since sales representative interacts directly with the customer, they know customers what customer wants. They know their customers. They know the behavior of the customer. The problem with this method that it tends to be overly optimistic, and the sales might be inflated by salesperson or the district manager while it's not. The fourth qualitative method uses consumer market surveys and questionnaires to collect customer feedback and capture their future purchasing plans. This method is useful for demand and product design and planning, but what consumers say and what they do are often different. Customer may be overly optimistic or are not able to answer questions regarding their future plans. For the quantitative approach, there are 5 common methods that can be recognized. Naive approach, moving average, exponential smoothing, trend projection, and all these models are considered as time series models that assume the future as a function of the past. And the last method is linear regression, which takes into consideration other factors that might affect the forecast. This approach will not be covered in this course, but most of the companies now they are trying to use this type of approach. Time series models predict on the assumption that the future is a function of the past and present will continue influencing the future. It's a set of evenly spaced numerical data obtained by observing response variable at regular time periods. A time series has 4 components. We have trend, seasonality, cycles, and random. Trend is the gradual upward or downward movement of data over time, for example, the change of income. Seasonal is a data pattern that repeats itself after a period of time, days, weeks, months, or quarters. The cycles are patterns in the data that occurs every several years, such as political events. Random variations in the data are caused by unusual situations. This graph represents the demand for a product or service versus time. And you can see through analyzing the graph, we can identify the 4 components of demand. The graph shows the seasonal peaks, it shows random variation, it shows the trend, and it shows the cyclical behavior of the data. The trend forecast that collected data will follow a persistent upward or downward patterns as shown in the diagram. Over years, data will follow certain trend that can predict future behavior of the data. For example, in some cities or urban areas, the data shows a trend of growth or increase in population. Seasonality is a data pattern that repeats itself after a period of days, weeks, months, or quarters. For example, restaurants experience weekly seasonal pattern with Saturday being the peak of the business. Other seasonal patterns could be related to weather or sport events such as football, baseball, or basketball seasons. The seasonal component has a regular pattern of up and down fluctuations. These patterns occur within a single year. The cyclical component are patterns in the data that occur every several years. Predicting business cycles is difficult because it might be affected by political events, economical changes, or other related factors. The impact of any factor will be noticed over a longer period of time. Random variation are changes in the data caused by unsystematic or erratic fluctuations. Data will not follow obvious patterns, so they cannot be predicted. Using trend, seasonal, cyclical, or random data, we can forecast the future through different approaches. The first one is the naive approach, which is the simplest approach to forecast through assuming that demand in the next period will be equal to demand in the most recent period. For example, if sales of the last month were 120 cell phones, then sales of this month may be 120 cell phones. For some products, this approach might work and be cost effective actually. It could provide a starting point for other approaches, but it's not the best, but it can be a start point. The second one is the moving average approach or method. A moving average approach uses number of historical actual data values to generate a forecast. Moving average forecast is useful if we can assume that market demands will stay steady over time. A 4-month moving average is found by simply dividing the sum of demands during the past 4 months by 4, the number of months, and the result will be the forecast of the coming month. The example in this slide is using the 3-month moving average. So if we were to forecast the sales in April, we add sales from January, February, and March, then divide by 3. That is 10 plus 12 plus 13 divided by 3, which is the 3 months, or 35 divided by 3, which is equal to 11 and 2/3. Although the prediction was around 12, 11 2/3 is like 12, the actual was 16. Can you forecast the sales for the other months of the year from August to December? Use the same method that we are using here from April to July. Go further and see if you can find or predict the sales from August to December. Consider that as like an exercise for you to learn how to do it. Although the moving average approach predicted the trend, but it was a little bit off from the actual, as you can see in the graph. Since there is a trend to forecast as close as possible to the actual, we can use the weighted moving average approach, where older data are less important. The weights will be assigned to each period based on experience and intuition. The weighted moving average will equal to the sum of weights for period n multiplied by demand in period n divided by the sum of weights. So going back to the previous example, if we assume that weights apply to this type of data and that recent month will have the weight of 3, while the one before will have a weight of 2, and the one before that the weight of 1, then the assumption of the weight will be 6, or the summation of the weights will be 6. Using the equation of the weighted moving average, it will be the sum of 3 times 13 plus 2 multiplied by 12 plus 10 multiplied by 1, all divided by 6, which is again the sum of weights, and that will equal to 12 and 1/6, which is closer to the actual from the moving average approach. Both simple and weighted moving averages are effective in smoothing out sudden fluctuations in the demand patterns, but they have potential issues. If we increased n, it would smooth the forecast but makes it less sensitive to changes. Moving average does not forecast trends well, and it requires extensive historical data. This graph compares moving average and weighted moving average with the actual sales. You can see that the weighted moving average predicts closer to the actual, but not with a lot of difference than moving average. The exponential smoothing is a form of weighted moving average where weights decline exponentially and the most recent data weighted the most. This method requires a smoothing constant called alpha that ranges from 0 to 1. This constant will be subjectively chosen. The exponential smoothing does not require a lot of past data or record keeping. The forecast using the exponential smoothing method can be calculated by adding the last period's forecast to alpha multiplied by the difference between last period forecast and last period actual demand, where f of t is the new forecast, f of t minus 1 is the previous period's forecast, alpha is the smoothing factor or constant, which should be between 0 and 1, and a is the actual, t minus 1 is the actual demand for the previous period. The example in this slide assumes that Ford company was trying to predict the market demand for Ford Mustang. The predicted demand is 142 Ford Mustangs. The actual demand is 153. Smoothing factor or constant alpha is equal to 0.2. Substituting the values in the exponential smoothing formula, the new forecast will equal to 142 plus 0.2 multiplied by 153 minus 142. That is 142 plus 2.2, which will equal to 144.2 or around 144 cars. Giving less weight to the older values by increasing alpha will get the forecasted values closer to the actual as shown in the graph. The objective of using this method and choosing alpha is to obtain the most accurate forecast. We can actually select any method that will provide the lowest forecast error. The forecast error is equal to actual demand minus forecasted value, or AT minus FT. In this approach, alpha will be chosen to reduce the variability between the actual and the forecasted values. There are lots of measures actually that can be used, and there are many other forecasting methods. So we can measure the forecast using different ways. Again, as we said before, the regression and other methods. We can measure the error in the forecast, but this course will not cover these topics. These topics can be covered in ATI 4640 if you are interested. That will be all for this session. Thank you and have a great day.